Morning, folks. New week means new things for us today. Here's what we got kind of planned for you for the upcoming next 3 or 4 days. Um, we're going to introduce you to a new app that we want you to work on a little bit. This will be helpful because this new app allows you to see a stopwatch, so it has kind of a timestamp embedded into slow motion video. So the way that we're going to use this is we're going to record some of our lab for Friday. But in order to get the hang of it, you need to practice that on either Tuesday or on Thursday, okay, depending on your hybrid schedule, okay? When you're in class with me, what you're going to do is we're going to take a three question quiz. It's going to be on kinematics only. All right, you're going to get a VF squared one, and then you're going to get the new one from today, and then you're also going to get an old question from likely an average acceleration type of one, okay? That'll be an open note, all that sort of stuff. But it'll be an in-person one for us. All right. If you're here on Thursday, that's what we'll do on Thursday. Distance learners, I'll email you separate to make sure that you understand what the plan is for that. All right. Otherwise, today we got kinematics, and I want to run through just a bunch of different ones for you with that. Okay. So here we go. All right. So we had the VF squared one last week on Friday. Now, we talked about it, ran it a little bit, but didn't do too much with it. So there again, there's your VF squared equals VI squared plus 2A delta D. Then delta D equals VIT plus 1/2 AT squared. So make sure you have those written down somewhere. Obviously, if you're in the classroom, they're going to be up on the front board. If you're not in the classroom, then obviously you want those somewhere in a notebook, circle starred, highlighted, written in a different color font, something like that, okay? Just so that you know, units of measure that we have to have for this, our velocity has to be meters per second. So if we're looking here at for example, let me get a different one. If we're looking here at VF, right, that's got to be meters per second. If we're looking for our acceleration, right, that's got to be meters per second squared. Our change in distance, or delta D, is going to be in meters, and then our time has to be in seconds, okay? Now, top one. To be aware of which one we can and cannot use so that we don't have to force kind of each question into each of its own. For the top one, if you're given time, can't use it, all right? That means that you have to use the bottom one if you're given time, or the average acceleration, okay? If we're given, wait, no, this one, we can't use if given distance. No, that's actually can't use if we're given, not distance. That's going to be final velocity. So if they give us final velocity, we can't use that bottom one at all right? Distance is able to be used in there. Initial velocity is able to be used. Now, the one thing to be cautious with this bottom one is sometimes if they give us that initial velocity and they're solving for t, it gets a little bit messy. That's where we may need a quadratic equation and stuff like that, but likely we're not going to actually run that type of problem here for us, okay? All right, so here's what I want to do. I want you to, if you're at home looking at this, you know, and you want to FaceTime somebody through this portion of the lecture, go for it. If you want to, you know, figure out how to get them on a Google Meet or something like that so that you can work through these, that'd be absolutely fabulous for you. All right, so first one out, here we go. If an airplane is traveling at 150 meters per second, then accelerates at a rate of 15.5 meters per second for 5 seconds, how far will it travel in those 5 seconds? Here again, we start looking for numbers for us, right? 150 meters per second, we know that's a velocity. As soon as we see the term then accelerates, we know that that's an initial velocity, all right? As we see here too, we've got an acceleration. It tells us how long that, or how much acceleration that has. It also tells us how long at 5 seconds that went for, all right? We want to know how far. So in this case, because they want how far, they gave us an initial, they gave us an acceleration, and they gave us a time. We don't have a VF. So if we start cruising through the formulas, VI doesn't really help us with much. We can still use the average acceleration one, right? Average acceleration, again, doesn't help us. We can use average acceleration and the VF squared one. As soon as we see time, That's the one that tells us now too, we can't use the VF squared one anymore. Because it's looking for how far or looking for distance, then we know we can't use average acceleration. We have to use this delta D equation, okay? So we start plugging numbers in. So it's 150 times 5. That's going to be our initial velocity times how long it's going for, plus 1/2 the A, which is 15.5 times 5 squared, all right? So for this one, we see 750 is our first part. That's 150 times 5, 193.75. That's the 1/2 AT squared all put together. We see this airplane should have traveled in that 5 seconds about 943.75 meters, okay? Um, Again, the reason why we chose this one, we had time, and we didn't have a final velocity there as well, okay? So, another set of practice problems, all right? So what I want you to do here again is put this video on pause so that once you pause it, you can run through these. Try them without the aid of notes, or I'm sorry, not notes, but without the aid of me walking you through them, all right? So go ahead and pause it here for a second, and then we'll talk to you on the kind of tail end of this thing. All right, here we go. Number 1, okay? There are some answers for you just to see so that if you did them right, so check them out quick. The first one, the distance is about 417 meters. The final velocity is about 26.3. For the bottom one, our final velocity is about 437 there, okay? So here we go, first one. All right, how far do you travel in this 18 seconds? If you start at a constant 20 meters per second, then you accelerate at 0.35 meters per second for 18 seconds. Here again, what we're going to see is that there's our velocity, right? Once we see the term accelerate, then that means for us that that's our initial velocity, right? There's our acceleration, and there's our time right there, all right? At this point then, because we're looking for how far, that means we want to use our delta D equation, right? So we put in our 20 meters per second, 18 seconds, 1/2, 0.35, 18, run that through a calculator, and what you should see is that thing comes out to about 417 meters, okay? Part B, how fast are you traveling after 18 seconds? All right, so now we again have velocity, we have our acceleration, and we have our time. For this one, it's a little different though. The reason it's a little different is because it's asking for how fast are you traveling after that 18 seconds. So we want an actual final velocity. So we see our initial is 20, all right? We see our change in or our acceleration is there. We see our change in time is there. So we can, if we want to, go ahead and use kind of a couple different formulas here. So I'm going to split that or fence that. And what you see here is we can use this based on our given information. All right, meaning that we can use and find and solve for VF, all right, or we can plug it back into the VF squared one. Either option, the nice thing is that both of those are going to work. Over here, you got to remember to add this 20 over at the end, okay? Otherwise, the math should be pretty straightforward, 18 times 0.35, okay? This one over here on the right, what we want to do is we're going to plug in our 20 squared, which is our initial velocity. Now, this 417, that came from part A. That came from how far it traveled. Now, if you're worried about using that previous answer in there because you may end up seeing that it's wrong or something like that, please know that if you get this one wrong in part A and then you use it from there forward, what I'll do is I'll get a calculator out and I'll see what should your answer be. Does everything else work out okay from that point on? Then that's fine. I'm not going to double dip you here. I don't think that's right. So what we end up seeing is that we can multiply that all together. Our final velocity squared, remember the squared term still here, is 691.9. Square root that, we should find that for this problem, we get a similar answer regardless of which way we take this thing, okay? And that answer will be there for us. All right, question number 2. If an airplane starts at a velocity of this and accelerates at 35 meters per second for 2,000 meters, how fast is it traveling at the end of that 2,000 meters? Well, again here, we want the final velocity. We know it starts here and accelerates. So that's our initial, that's our acceleration, all right? and we know our distance here. So we start plugging stuff in. The 225 goes in the VI squared. The 2 times the 35, that's our acceleration, and the distance there is our 2,000. Plug all that stuff in, and notice I did the square root early this time. It's up to you. You can do it whenever you so choose. I just showed it earlier here to just show you a different way of presenting this thing, right? But at the end, we still have to take that square root of that 436 and or whatever number this is in here, okay? All right, last set, okay? Last set of problems for you. So try this one out. We got a little different thing here. Now, this one, we've got a negative acceleration, and we're also looking at how high up this thing goes, all right? Then also try the second one. Again, deceleration. It's going to be a little bit different for you on that one, okay? Give those a shot. See how you do, all right? Okay, let's check them out. See how you did. All right, this one I went old school on and just took a picture of my work because it was a little easier. Delta D we see is we don't know that. There is no time, so I don't even know if I would put that in there necessarily, just because that could mess up some people. VI is 75, VF is 0. At the apex, remember, that's where stuff stops. Basically, it goes to 0, all right? Our acceleration is negative 9.8. So if I put this stuff in, I get 0 squared, 75.1 squared, plus 2 times negative 9.8 times delta D. All right. Move that over so that that becomes positive. I get 19.6, right? That's my 75.1 squared. That's 2 times negative 9.8. I see I got 19.6. I got 5601 divided by 19.6. This thing should, if I launch it at 75.1 meters per second, which is about 160 miles an hour, all right, this thing should go up about 288 feet into the top of the air, all right? Again, notice the difference here is that now we solve for delta t. We give you a little bit different variable to look at, a little bit different variable to see, all right? All right, last one. Here again, we're looking at a similar style of problem. The difference is here again, we don't have t. Our distance, 0.01. Our initial velocity, 50.5, and then 0 at the stop point, okay? So we go 0 squared, 50.5 squared. So then that becomes 2,500 plus 2 times 0.001, all right? So 0.002a, add that over to the other side, all right? Once we add that over to, or I'm sorry, subtract that over to the other side, whoop, look at this. Boop. Should have a little negative sign in there, right? Because this thing should be decelerating. So we take 2,500 divided by 0.002 negative, and we get negative 1.3 million meters per second squared, which is a big slowdown, so to speak. All right. Homework will be available today. I would encourage you to start looking at it, working through it, seeing it. That'll be helpful for you as well to get a better understanding of how to run some of these problems. We will pull problems from homework for that paper copy of the quiz. So just be aware of that and make sure you take a look at it. All right. Otherwise, have a phenomenal day. Make sure you get outside, enjoy the nice warm weather that's supposed to be around, I guess. So I'll talk to you. All right. Have a good one. See you. Bye-bye.